Hello everyone, my name is Marcin Kubacki, I'm Chief Architect at Storware, and today we are going to have two presentations. One related to Red Hat Virtualization, well, its new features in a recent release 4.2. That is going to be covered by Jacek, Solution Architect at Red Hat. And just after this, his short presentation, I'm going to briefly introduce you to Red Hat backup strategies that we are able to execute, and we will be able also, because there is one more additional strategy that I'm going to cover. It's not there yet, but it's coming soon, on the ref/oVirt environments. Okay, so Jacek, let's start.
Okay. Can you hear me well?
Yeah, I'm hearing you perfect. Everyone should be on mute right now.
Okay.
So let's go.
Good morning, everyone. My name is Jacek Skórzyński, Solution Architect, as Marcin said, at Red Hat. Today, I would like to introduce you some new features, some set of new features I chose for today in Red Hat Virtualization 4.2 version, which we just released about 1.5 weeks from now. So let's jump in. Let's see what we have in the new version. From the start, when you log into the user interface, you will see that this is totally different one, and there is nothing. This is nothing in common. There is like a lot of features. The whole user interface was redesigned, and it uses a pattern flying engine, which is the same one which you can observe in CloudForms from some time. So looks like pretty similar. The user experience is in my opinion, my personal opinion, much better. So during my short video, which I would like to present to you later after this presentation, you will see how it changed and how it looks like now. Okay, the next thing, which is really cool, really powerful, in my opinion, is a native disaster recovery. So we rely on a stretch cluster right now, which is the configuration is active for sure. And the second thing which we rely on, which is worth to mention, is Ansible automation. So everything is done during the disaster recovery from one side to the other. It's done by Ansible. So we put a lot of Ansible effort in it to make it work, and it's done. Yeah? It's there right now. Next thing, really cool, the feature which many of you was waiting for is a networking part. I mean, there are two parts I would like to concentrate on. One thing is the ability to join or to start working with the external providers from Red Hat Virtualization, which was in the product from some time. But right now, there are cool new things like Cisco ACI already implemented or integrated with Red Hat Virtualization. So right now, using Cisco ACI, you can also integrate your network from Red Hat Virtualization. The second thing, of course, is OpenStack Neutron networking, which is still there and still developing. The second part I would like to concentrate on with these networking features is a native OVN, Open Virtual Network, which is based on Open vSwitch. which you could use as a tech preview in version 4.1, but right now with Red Hat Virtualization version 4.2 is fully supported. Next one, metrics and logging. This is something which was really missing from the product. We did not develop, or we just skip the project, which I missed the name, was till the version 4.0. And right now with 4.2, we have an integration with Elasticstack. So you can see in the documentation that there is an option, for example, to integrate your Red Hat Virtualization 4.2 with Elasticsearch, with Kibana, which could be a part of, for example, OpenShift platform, or just the one which you already have, maybe in your environment. So the next thing worth to mention is metrics and logging based on Elasticstack. And the last one, which I would like to present to you today, is support for CEPH via iSCSI. So finally, we can connect CEPH storage directly to Red Hat Virtualization, and it's fully supported from the version 4.2. Previously, you could do that also with Cinder integration, partially from using OpenStack platform. So OpenStack has to be a gateway to make it work. Right now, you can use and it's, as I would like to express it once again, fully supported CEPH storage via iSCSI in a Red Hat Virtualization. Yeah, that gives you additional deployment choice if you already use CEPH, or you would like to use it with maybe OpenStack. This is another type of storage you could introduce to your ref environment. Okay, that was it about the new features. I would like to also point you to some documentation. There is lots of new documents on the Red Hat page, Red Hat docs, in the Red Hat virtualization sections, and here some cool blogs about the product. All right, that was really fast intro into new features. Right now, I would like to show you a quick video with a presentation of new user interface. So let's have a look. The intro screen is more or less the same, but as you can see here, there is a bunch of new things. Dashboard, it's similar. It's actually the same one from the previous version. And as you can see, this is the video is made on our Red Hat's internal ref environment, which we use for our Red Hat purposes, internal purposes. And so we already use this version 4.2 for some time with a great feedback from admin guys. So what you can see here that everything is redesigned, but most of the things, most of the informations which you used to from the previous version is there. So when you would like to create a virtual machine here, most of the screens are similar. Or when you would like to run the machine or make a migration, everything is under your control and really intuitive to start with. I think it's a good option and a good start to rediscover Red Hat virtualization from the beginning with this new dashboard, new user interface, which you can see right now. Okay, that was basically it from my side. Marcin, as I promised, I took 10 minutes, maybe 10 and a half. So I was...
Thank you, Jacek, for the presentation. Great, great news about this RHV release. Are there any questions? You should unmute yourself or maybe type in questions in the chat box. We'll try to answer them now. If not, we can postpone it until the end of the presentation. So let's wait for a couple of seconds. Maybe somebody has additional questions. Okay, in the meantime, I'll prepare my screen. So now it's time for the second presentation. So what are the backup strategies related to RHV and oVirt environments? Actually, it's a good opportunity to talk about the protection of these environments. So Jacek has already said about the disaster recovery process. Well, you need backup always, regardless of if you have a disaster recovery configured or not. And we see that RHV environments are gaining more and more popularity among the users, and the infrastructures currently being built are well, quite often built on these environments. So today I'm going to give you a brief introduction to the vProtect itself, with the focus on these three backup strategies that actually we support or we will support in a close future. We started with several other platforms, especially with Citrix actually, but oVirt and Red Hat are, well, let's say, mostly supported platforms by the vProtect right now. So as you can see, the range of the platform supported, well, this picture actually doesn't show Nutanix, which is also another KVM-based hypervisor, but we support more and more platforms with every release. In general, vProtect's architecture looks like this. So you have some virtualization environments, RHV manager with all of these hypervisors behind the scenes. There is a node or more nodes, and these nodes are snapshotting and exporting data, put it in some staging space, and later forward it to some backup provider. So that's the basic flow, how the vProtect works in general. We want to make consistent, at least as far as this scenario is concerned, we want to make this scenario consistent across all of the hypervisors. That's sometimes quite hard because all of the different vendors use a little bit different, they actually name the same things but differently. They have different concepts, different data models, but we want to make user experience in general to look the same. So you have a bunch of options on the right side, you have a bunch of options on the left side, you can mix them together, and eventually you can end up with a single pane of glass covering several different technologies in your data center. vProtect consists of two components, node and the server. Server manages multiple nodes. You can think of a node as a data mover. So technically, it's node who does the dirty job. He creates snapshots, export all of the data, and puts it in some backup destination of your choice. And vProtect server is the central point where you are storing metadata. Key features, especially related for the RHV environments. So we wanted to make sure that we are using everything that as Red Hat has described. So we are using native APIs, And that means that we are supporting REF environments and oVirt environments since version 3.5.1, something around this. Later, Red Hat introduced oVirt 4 and API 4 in general. That we also have added additional support for this API. That will be a secondary backup strategy that I'm going to cover. And finally, we have REF 4.2. But that corresponds to the oVirt 4.23, and this also is going to allow us to have third strategy for backing up virtual environments. File system freeze. In next release, we are going to, well, file system freeze is native mechanism built in REF itself, but in some cases you want to have your own scripts to quiet database. That's one of the features that we want to include in the next release. You'll be able to execute remote commands on the virtual machine, quiet your DB before being snapshotted, and later resume the database. Option to exclude selected drives. Depends on the strategy, but for the new strategies that we are offering for REF 4, you are able to exclude some drives from the VM. You are able also to mount those backups later without having to restore them into your environment. We often meet customers that have multiple hypervisors, many VMs. It would be quite unmanageable for the administrator to assign all of these VMs to schedules, groups, etc., etc. We introduced, well, it's been a while, but we introduced a mechanism that actually helps administrators to automatically assign VMs based on tags and names. So you are able to use tags, assign them on the REF environment, and vProtect periodically scans for the infrastructure. He will detect the changes and assign VMs or remove VMs from the groups based on your tags. Finally, API for integration. That point actually is gaining more and more attention around the world. Actually, administrators want to have some central point for orchestration of their data center. It's quite often it's cloud forms. It can be anything else, but in general, API it's key for integration. So we expose our API. And today I'm going to actually show you a small integration, small proof of concept, how it can be integrated with the cloud forms, for instance. Backup strategy 1. That is what we have been doing so far. It's the first approach that we have implemented, it was even last year. And basically what it does, we are using export storage domain and attach it as over NFS to the REF. This export storage domain corresponds, it's one-to-one, it's the same file system, it's actually our staging space. That means that vProtect asks for the backups to be exported, then REF exports VM as a whole to the export storage domain, and we are able to grab files and push it to some specific backup destination. And well, export storage domain, it may sometimes be troublesome for managing it. That's one disadvantage. Another disadvantage is that export, by default, using export storage domain, exports VM as a whole. So there is no option to exclude drives, for instance, in this approach. And one of the concerns that administrators sometimes have is that it's doubling writes. So you have to write on the staging or on the export storage domain, then it has to be moved to the file system or any other backup destination that you have. Technically, this picture actually shows it's a great example, because we had also been testing with DD Boost file system scenario where export storage domain was exactly the same as staging space, which was exactly the same as data domain file system used as the backup destination. That means that technically, first step, export, was being done, well, it has been done just directly to the target backup destination file system. And because vProtect checks if the file systems are actually the same, he thinks, well, if I don't have to copy files, I will move them. So technically that would result in a single write, even though we can see in the picture that actually we have three places. I have export storage domain, I have staging, and I have target backup destination. So it can be set up in this particular scenario in such way that you are able actually to have a single write. Another disadvantage actually is that it requires additional cloning. So there is no way actually to export VM directly using this method from the snapshot. But then, well, we have designed the vProtect strategy. vProtect actually supports additional strategy since not recent, well, recent release actually. This year, actually, we have introduced support for RHV version 4 API. That means since 4.0. It doesn't mean that you cannot use the other one, the previous one, with your current RHV or oVirt. It works as well, but you have choice. So if you have a newer version of oVirt, like 4 something, you're able to use disk attachment. So this is currently available in vProtect as Red Hat Virtualization version 4 Hypervisor Manager. The approach is completely different in this case. So you don't use export storage domain. Let's forget about it for now. You have to deploy vProtect node as a VM. And using disk attachment method, you have actually way to deploy, well, you deploy several of these nodes. And vProtect nodes are attaching drives, dumping data, and later they just push everything to some backup destination. So this actually gives several advantages. Okay, so first of all, there is no export storage domain requirement. That's a plus. Additional, well, API version 4 is being used. We have received also some requests from the customers that they want to use API version 4. And yes, that is currently supported API version. We want to stick to the most current version, and we want to make it as up-to-date as possible. No additional cloning required. Since, well, we are able to attach drives online without having to actually wait until the VM is down or something. We don't have to actually make the VM being offline using this approach. We are just able to dump data from the snapshot, right? So in this case, that's additional advantage. There is no additional cloning requirement. And finally, because we are controlling which drives are being backed up, we are able to exclude drives that we don't need. So you are able to deploy multiple of these nodes on each of these clusters that you are supporting and manage them centrally from your single vProtect server environment. In vProtect, obviously, you're able to point all of them to a single backup destination or to separate backup destinations. That's always your choice. Cons, well, more complex backup process. It's technically from the user perspective, it's not that hard to be set up because he doesn't have to set up the export storage domain. The only requirement that you may face is LVM configuration, so that LVM, it's not going crazy if he sees the same, because quite often you are cloning VMs from your templates, so he's not going to go crazy if he sees the same volumes twice. So you need to prevent it from scanning LVM volumes. But that's just a short step to be accomplished. Finally, backup strategy 3. This is what we intend to introduce. Because RHV and oVirt 4.2 well, are pretty mature right now, so we are able to use new APIs. So if you have oVirt 4.2 or 0.3, let's say 4.3, or RHV 4.2 current release, you are able to use this. You will be able to use this backup strategy. So there is a snapshot change mechanism. So new APIs offer in RHV ability to export directly certain snapshots directly from the API. So you're able to fetch all of the data or just, that's very important piece, part of the data. And we intend to add support for incremental backups. So the advantages are obviously, again, no export storage domain. We are using new API, no additional cloning. This exclusion also stays the same. We are able to obviously to control which drives can be backed up and which not. This time you don't need proxy VM actually, because technically vProtect is able to talk with the external services, with Ref Manager, which is responsible for actually giving us access to the data. And that is the first step where we actually, first moment where we are able to implement incremental backups. So still, to be accurate, Red Hat Virtualization doesn't support change block tracking. However, their APIs make possible to create incremental backups. So it should work basically almost exactly the same. In this strategy, we obviously are able also to mount backups and do the same stuff as the backup strategy too. Cons, obviously, not everyone has 4.2 ref already installed. It's pretty new, but it's eventually is going to happen. It requires snapshot merge, obviously. Whenever you are creating incremental backups, sometimes you create your own snapshots. We have to merge them during the backup process, and we have to also to merge that during the restore process. It takes additional time, but gives you option also to mount incrementals. And finally, well, that's even more complex backup process, okay? So behind the scenes, a lot of things are going to happen. From the user perspective, as always, is going to stay the same. Where my backups can be stored? That's actually a key question. So you choose vProtect. Well, one of the reasons why you choose vProtect actually is that you have options to store backups in basically everywhere. Okay, so that may be a little bit, well, too big word, but in general, you are able to attach file systems, everything that is mountable, even though these that support the duplication or replication. You're able to use block storage. You're able to use enterprise-grade backup vendors. With them, you have additional options to backup to tapes or whatever they are supporting right now. So that's one of the things that you need to consider when you are actually going to implement backup. First of all, what is your strategy? Which version do you have of your ref environment? And second question is, where actually you're going to store your data? It's very good to tell one more thing about the local storage, well, file system basically. Because vProtect is able to read directly, it's actually random access from the vProtect's perspective. Restores or mounts or imports, they don't require additional data cloning. So vProtect doesn't need to download data like from S3, for instance. He's able to grab files directly, and he proceeds with mounting or importing data to the ref manager. This strategy that I have mentioned actually differ as far as the restore process is concerned. So let me go back for a moment. Restore in export storage domain approach is actually again to the export storage domain. So you are able to restore your VM from the VM import tab in your oVirt. Disk attachment and the snapshot chains requires import from the vProtect. So technically you are just choosing which hypervisor manager you want to VM to be restored, which cluster, which storage, and vProtect does two steps for you. So he will eventually, you will end up with a VM already restored on the oVirt or ref. That's additional example where you can store your backups. This actually describes a little bit more details how IBM Spectrum Protect in this case can be used to store your backups. And this also shows two-step process involved. Okay, so first we export data, that's actually one task in vProtect, and later we store data. So that is additional task that needs to push data to the IBM Spectrum Protect server. We quite often receive questions about the staging space. How do we size it? Well, it depends obviously on how many simultaneous backups you want to invoke, how big are your VMs. But in general, it has to be big enough to hold temporarily those VMs so that we are able to actually to process them and later to store in some backup destination. vProtect can be set up sort of like a two-tier data protection system. So it can actually keep last backups locally. So if you have some remote S3 or let's say cloud where you want to store your data, you're able actually to ask vProtect, just leave last backups in the staging space. Then you have instant restores. I mean, instant in such case, well, it doesn't need actually to download the files from the internet. So that boosts the restore process eventually if you need them, because he's reading just local files. As whenever I say S3, it's actually a good opportunity to notice one thing. S3, it's not only Amazon. Technically, we have some additional options that you are able to set in our connector, in the backup destination properties, that you're able to point to technically any S3 compatible backup destination, well, some storage. So if you have, let's say, scalability S3, you're able to actually to use it to store your backups with this connector, or IBM object storage also, as well. That's a screenshot of the CloudForms integration. So the last thing is the API. So once we have the ref installed, it's quite often that we want also to install CloudForms. We attach to our existing ref manager, and we want to technically allow users sometimes to back up their own instances just from the CloudForms management engine. So vProtect is behind the scenes. He does the job. He has obviously his own UI, but we are able to expose just the tiny bits of the functionalities that are required for the end users to be used. So let me go through the 3 steps that you commonly will go through whenever you're installing and starting with vProtect. First, you obviously install 2 RPMs, like server and node. Then you are connecting to your backup destination. It can be file system, S3, whatever. So you set up connection with your backup destination. Then you are connecting to your ref manager or oVirt manager and invoke scan. So index VMs technically updates repository, local inventory actually, in vProtect, so you're able to see all of the VMs and all of the hypervisors. So you don't need to type in all the hypervisors manually. You are able just to invoke a task. Finally, once you have those VMs, you are able actually to backup them, restore on demand, but you also want to create groups and schedules. So group of the VMs is assigned to set of schedules. And this group will be backed up every time where the schedule is being invoked. Let's say once per week, or you have 2 schedules, one for incremental backups, one for full backups. Well, incremental is actually coming soon still, because for these 2 strategies that I have mentioned previously, the first export storage domain and disk attachment, this is full backup only, and incremental is the thing that we intend to deliver with the third strategy. Finally, you're able to restore, mount backup, your backups whenever you need. So let's do the demo. Do you have any questions up to this moment? Okay, let me check, maybe something in the chat. Does vProtect support CEPH? You mean as a backup destination, probably. I guess so. well, we don't technically check all of the file systems in the market, but everything that you're able to mount, okay, and expose, well, mount somewhere in the vProtect, technically that can be your target. That includes like video, for instance, that has been recently also made available in CentOS, if I remember correctly. So that gives you the deduplicated file system option. Gluster.fs is another good example of having a file system that can be replicated among two nodes. So now, let's say, well, this is our environment. You can imagine that vProtect node and vProtect, well, node 1 and node 2 have the same file system being replicated, and whenever vProtect 1 backs up something in the first data center, it enables secondary vProtect also to restore it in the secondary data center. So that's one of the scenarios that we also have been covering in our tests. That's one of the ways to back up your VMs and restore them using them. Well, that's how to use multi-node architecture that I have been mentioning. Okay, anything else? Okay, so let's continue, and if you have additional questions, we will have time also in the end, at the end of our presentation. So what I'm going actually to show you how, okay, so this is our demo environment. It consists of several platforms, so we have 3 nodes available in this environment. We are going to use this one. This is the local, it's installed together with the vProtect server. And this one, this is the node installed on the oVirt as a proxy VM. So our infrastructure has all of these nodes running, and you are able to assign sort of node configurations to match common settings for all of these nodes, especially number of tasks that can be executed simultaneously, some settings for the hypervisor related, especially like storage domain mappings if you have older ref environments, and so on and so on. One question about the export storage domain that we quite often receive is, well, okay, storage domain has limited capacity. What happens if it gets full? vProtect has built-in mechanism that he actually allows him to detect if there is some, well, the free space available is actually shrinking, and he's able to, well, at least for a moment, hold with the additional export task being executed until store tasks just remove temporary data once they finish their job. So vProtect is able to balance it properly. So first step was actually to add hypervisors. As you can see, I can choose between 2 types. It can be either the old way, like I'm going to use on the vProtect node 2, or the new way with the disk attachment process, like it's already configured for the node, oVirt node that I have in here. And whenever I invoke index task, it appears here in the task console. He connects to the hypervisor manager and gathers all of the necessary information like hypervisors, what are some storage available later to be used, is it local or it's connected to some cluster. This is OVM. This one is actually OVM again. Its cluster is actually for the ref environments. So as you can see, there are cluster and default. These 2 clusters are available for our environments. So let's initiate some backups. This will take time, and in the meantime, I will be able to have a short walkthrough. Okay, so let me actually invoke a backup to the IBM Spectrum Protect, and the other one. This one is much smaller, so it should actually end up much faster. So I have 2 VMs in the queue. As you can see, 2 separate nodes address their backup process. So let me start with the with the export storage domain. Export storage domain is on the ref manager. So let me connect to the Red Hat virtualization. Here in the storage, you are able to notice that there is an export storage domain configured. This corresponds, well, actually there is a shared storage connected to via NFS that we are able to expose, and that gives ability to vProtect to see the same storage as ref manager sees in their data center. So what we actually see here in the events is the process that has been initiated. First step actually is to create a snapshot. Once the snapshot is complete, vProtect will be able to create a new VM. And once this VM is being cloned, we are able to export it. So this is a three-step process. So currently, we have finished snapshot creation. It creates a clone of the VM so that we are able to create an online backup of such VM and export it directly to our storage. In the vProtect, we see that it is around 10% of the progress. So technically, it means it has successfully created a snapshot and he's now creating the clone. This may obviously take a while. In the meantime, we have oVirt. So let's log in and see what happens. This is, well, technically you can assume that these environments are quite, well, they are almost the same as they correspond to the newer versions of the oVirt. The approach, like the proxy approach, works also on the 4.0 version of the oVirt, so it's exactly the same. In this case, I have my proxy VM running here in this VM. You actually can see the difference here in the vProtect. When he invokes a scan, I have invoked that previously, it shows the proxy VM UUID. So it detected that vProtect node works on this VM. So that is why he is going to be able later to distinguish to which VM disks that are being backed up need to be connected, need to be attached. Okay, so export storage. This export will take much longer. The VM is much bigger, and the approach is much more complex. So I expect now in the oVirt that few messages have appeared. So he's creating snapshot. This will take a while. He's currently executing and creating additional volumes. But let me have a quick walkthrough what is going to eventually happen. This should take around 20-something minutes. What is going to eventually happen in this particular backup strategy. So here you can see from the log, let me just have, okay, this looks like a completely new VM backup that we have seen in the log. So virtual machine has separate drives. vProtect tries to attach and detach drives one by one and dump data in between. So during the backup process, actually there should be one of the events here. As you can see, there is this disk 3 that has successfully been detached at some point, and another drive has been attached and proceeds with the data dump. So once all of the disks are processed, technically, well, the snapshot is being removed and the backup completes. So this doesn't require additional cloning. This just dumps data as it is directly from the VM. We see that just currently we have successfully completed the snapshot, and now vProtect proceeds with the disk-free attachment. So it has attached the drive. Let's see how it works. we see that this CentOS 7 that we are backing up disk is already attached, and we see that the snapshots, well, we don't see it here in the list. And vProtect actually proceeds with the data dump. So this is right now should appear here. Oh, okay. So this will take a while. Keep in mind that vProtect actually verifies twice in several cases if the disk attachment has succeeded, if the disks are present not only in on the rev side but also on the operating system side. That is why those disk attachments may take a bit longer if the environment is not that responsive. In the meantime, actually, we have completed a small backup of 1 gig VM using the export storage domain approach. So, okay, this already, as you can see, it has moved to the 10%. So he probably had managed to dump the data from the drive, from the first drive. Here, on the other hand, I have the export that has succeeded. So I can log in the meantime to our ref environment, and I can see that the once the snapshot has been cloned, once the export has completed, the clone and snapshot both are being deleted. Once we have that done, files are being moved from this table, moved, or in this case, they are actually being transferred to external IBM Spectrum Protect. This takes obviously additional time. However, it also enables you to transfer this data to some external site. Once you have these backups completed, you later are able to restore or mount backups. So here in this restore process, depending on what type of the hypervisor platform you have, you will have different options. Let me scroll down